address and my website is right there. So one thing very important, I am my lab is Zimmer Biomed in quote empowered lab, as Dr. Martin suggested that there's only 150 labs and I'm one of them. So Dr. Donna and Dr. Martin did a wonderful job explaining clinical procedures and the periodontal procedures. One thing about Dr. Martin is being a wonderful teacher and mentor to me, and his passion to dentistry and helping lab and clinician is so much that I call them all weird hours of the day and night.
Father's Day. He called me on Father's Day.
And he never missed picking up my phone. So thank you very much, Dr. Martin. So what I'm going to do here, I'm going to go through a few slides of the lab procedure, and then we're going to go actually a video, me designing a end code, actually it's a Zimmer case, Zimmer DSV case, end code, and then custom abutment and a crown and a model if we have enough time left. So my lab is fully digital, meaning either you take a digital impression, we will work through that, or you take a analog impression, we're still going to digitize it and work with our CAM software. So,
can you scan any impression material now?
Yes, we do, but most of the time we pour models first.
And scan them on?
Yes, even though I use 3-shape system also, and it can scan even a lower interior case, but we try to just pour the model first. But in some cases where we don't have time to pour the model, we can pour a impression also. But one thing, we only scan the impression when there is a post and core involved, because it's the negative impression, and we have much better luck in scanning the post itself in an impression. So right now our our workflow is such as Dr. Martin explained. Last 5 years we were doing only maybe 10 to 20% intraoral scans. But right now, in the last 2 years, it's just exploded, and we are about 60 to 65% intraoral scans. And our traditional impression that we receive is about 30 to 40%. So it's catching up, and now people have believe in it, and restorations are much. We can design a restoration much faster and a lot more precision. So. In traditional impression, we have scan, casts, and then or impression, or so. Then, reading from there, CAD is computer-assisted design, mean anything we scan already or intraoral scan, we're going to design with the computer software, and then finally, we're going to be doing computer-assisted manufacturing, which is CAM, which could be mill or 3D printing. So, when we compare the traditional impression to intraoral scans, with the traditional impression, traditionally patients have discomfort when you put that goop in the mouth, and then gagging sensation, material and logistic cost. When you take that impression, there's a cost involved, and then also sending it to the lab. And then the biggest thing, as Dr. Martin explained, once you take the impression, it's a copy of the teeth, and then we pour that impression, that's a copy of the copy. So you have a lot of inconsistency in that there. But again, it works, but now we have this intraoral scanning system, which are so successful and so advanced, and on top of that, higher patient comfort, easier retake. If you miss a spot, you can just go right back and just scan that spot, and it will stitch it itself, and lab is going to get a perfect impression that captured all the detail. And then also you can save the logistic cost. Problem, models still might be needed sometime, when we design a restoration, now we can go model-less. We can design a restoration which does not need the model, because software is so so precise, and also milling systems are so precise that our contact and occlusion, we can rely on that, and we don't really need the model to check for. But in some cases, we still need it, so we can go back and 3D print those models. So intraoral scans. These are all intraoral scans that we can receive their files and work with it. Some of them we have direct access to, such as 3Shape Trios, iTero, and Sarah. So that means you don't need to pull a STL file. There's a direct link from them to our portal, that as soon as you take the impression and click our lab name to it, it will send the whole impression. You don't need to do anything else. But then scanning system like 3M True Definition, Fine Macaque, Airstream, you have to pull the STL file from their scan to send it to, or even upload it to our website portal, or attach it as an email and send it STL file, so we can use them as your intraoral scans. Now, in a lab, we have all those three scanning systems, but as Dr. Martin said, 3Shape is our go-to system. We do receive directly from CEREC in lab and dental wig system, but every single intraoral scan we always convert it to 3Shape, because their design software is so robust that we can design, and this is Dr. Martin's favorite design system also. So the case I'm going to be designing it, it's going to be a 3Shape design system. So here's one thing. We're going to be designing this crown in Dental Studio Software 2017, even though all those CAD/CAM companies come up with the updated software every year, but then they have bugs and problems. So we just wait 1 year and always wait for all the bugs to be cleared, and then we install it so we don't have any workflow issue. So right now we're still using 2017 design software, and hopefully by December rolls around, we're going to have enough of that software bugs removal that we'll be able to install it in our system. So here we go. If you look at, and it could be pretty much any design system, we can scan an impression, we can scan a gypsum model, or we can take intraoral scan, and then it's gonna go through our order management system. If it is an impression or model, we're gonna scan it, but if it is intraoral scan, it's gonna go directly to the CAD system. And then from there, so at some point, let's just say we want to get you involved in the design process. We can either bring you can look at we can bring you in our system through computer. You can look at it, design process or design finalization on your computer screen, and let us know if you need any design changes. So from there we have, or we can send you a digital. If you have that Trio system, we can send you actually whole design back that you can take a look at it and modify it if need to, or let us know if you need any modification. And then from there, once our design is finished, and we have generated an STL output file, which is a manufacturing file, either we can mill, we can laser sinter, and 3D print, as Dr. Martin showed in the slide previously. So our 3Shape system is, as I said, it's from single unit to full arch design. We can do it. A lot of the other systems, and especially those CEREC systems, initially they were just designed for one unit or inlay-onlay type situation. Still, those clinical softwares are kind of not up to that speed, where if you want to design a full arch, that takes some time. But in our case, it's our daily basis. We can design those design full arch cases. So, as far as the design go, we can not only do the full arch, full arch cases, we also can design diagnostic cavaxa from extracting the teeth, designing, edentulous cases or veneers, or, you know, and we can superimpose on patient's picture. So, so you can see how they're gonna be. And then on top of that, 3Shape system has the best implant designing software. Do you agree with that?
It, it's, it has as many features as any, and most people,
Right.
even if they have multiple systems,
Exactly.
will go to the 3Shape
Exactly.
for their.
Even though I have other design system, but when it comes to implant, I only rely on 3Shape system. We can design our models, and then also we can actually incorporate our Facebook and condyle setting in our software also. And for instance, let's go back here. You know, we scan a model that is on the adjustable articulator. We can transfer that setting into our system too, because 3Shape system has the plate transfer, mean exactly the same setting that you have in your articulator. It could be transferred to our design software. So we can bring any adjustable articulator in the system, any articulation system you work with, any Facebook system you work with. We have a clinical validation tool, mean we can assess bite pressure, how much clearance we have, how much space we have between contact and the other side. So these are the systems that we use in the lab. This is our static system, this is our downwing, and this is 3Shape. So we use D2000 3Shape system that is the biggest and most powerful scanning system we have in the market. This is our mill, DWX50, and it's a dry mill, and it mills only zirconia. As Dr. Martin explained in his presentation, we looked at it many different metal milling systems from, and I visited 3i facility, Straumann facility, and some German implant system. We found it's impossible for us to go to that extent and mill titanium in the lab, because those machines are way too big and way too expensive. So, as I said, even if they are selling the blanks, labs wouldn't be able to afford those machines to mill that precise customer buttons. So we confine ourselves just to mill zirconia, which is a softer material, and mill very easily and very precisely. So, and then these are our 3D wax printer, mean any design output we can print our wax coping. You can see here. So if we don't want to mill in zirconia, we can either mill the wax, we can print the wax and cast it, or if it is Emax, we can press the Emax. So in the end, from CAD designing to CAM printing, then go back to the same lost wax process and either cast our copings or press our Emax crowns. These are our 3D printers, and these 3D printers, these first two are Form 2, Form 1, and this is called Moonray. So the difference between these three printers, first two printers are laser sintered, and this called DLP, means it creates the image like projector, so it can print much faster than laser going into each crevices and each places to cure that material. So this DLP is much faster, and they caught up to the quality of these laser printers. So this printer can print a model now in an hour and 10 minutes, versus these two would be about anywhere from 5 hours to 8 hours to print a tray that has a couple of models or quantities. So now I'm going to go to video.
Just, there we go.
There we go. Let me see if I have.
I think you're gonna have to do it the old-fashioned way, Sean,
Which way?
with your finger.
With the finger, yes, sir.
Got it?
Yes. I'm going to have to stay in here So while I'm, stop this for a second. So the way this video is made, I was designing a end coat abutment and a crown, and while we were capturing the screen, so I'm going to stop and pause and play. And meanwhile, if you have any question while it's being designed, we can certainly stop and you can ask this question. So we open up a order form in our lab system. Since it was a model, we scan a model first, and then from that phase, you can look at it here, we open up so in our order form, this number 28 that we are designing, there's a custom abutment, and probably you cannot read it, but it says Zimmer Biomet TSV 3.5 or whatever. And then there is a crown on top of that, which is a dual layer crown, as Dr. Martin suggested, that we try to cut back facially and always layer some porcelain on. From there, model is already scanned. The first thing what we do is we cut our axis of the model. So we're going to trim that, and you can see this encode abutment right here, about 2 millimeters above the tissue. So it's a perfect scan body that is there, and from there we can easily line up our scan body in the system. So this is how it gets done in the lab. So the reason we cut out that model, because more data we have, the slower it gets. So if we can cut out all extra stuff, we can design it much faster. We line up our occlusion. So this is where it shows us how our bite is. But just in case, if in scan your bite is incorrect, we can correct it at that stage. We can change that, upper or lower model in order. And if you look at it here, it shows us how much pressure we have on a bite. So green means -2, when you are brown and red, that's where it's touching. That's where our contact points are. So I'm going to turn off the color scan, and I'm going to work with the just a colorless black model. See, now I brought it a little bit more, so now we have very, very positive contact. And since we are going to print that model, so any holes we can fill it in digitally. So when we're going to be printing that model, it just comes out beautiful looking model. So the next stage would be where we're going to be lining up our scan body to digital scan body. So this is the time where I often call Dr. Martin, because sometime, as he said, sometime the scan body is sitting right at the tissue level, and we're not sure, so we usually call Dr. Martin to verify if those two scan bodies are lining up. So this blue scan body is actually a digital scan body in our system. So these two have to line up. in order to get the timing of the implant and the positioning of, vertical position of the implant. So you'll see I'll put some dot and software will line itself. There are some markings that we need to, actually in this case it's just only one dot, right? If it had been a 3i scan, then we had to put two spots. So in this case it didn't line up, so I'm going to go back and realign it. And this is the critical part of all this design process. We wanted to absolutely make sure that those two things are lined up perfectly. Now, so I'm going to evaluate from all different angles. So previously I was just using one dot to line it, but it was not lining up properly, so I went ahead and choose the option for 3 dots. There you go. So
I can't stress how critical this is, and as you mentioned earlier, if it's covered with tissue, it just makes it riskier. And we have good quality labs and we have sloppy labs, no different than every aspect. And we have to pay the price in the end when that lab is sloppy about it and you have a contact that's rotated 5 degrees. So this is very, very important to me. I can't stress it enough to the labs, and we spend a lot of time on working on making sure we spend the time to get this alignment right.
And Dr. Martin created this template. You should all get this, his monthly letter where he teaches labs and the clinicians what are the potential issues and their resolve, how we can resolve all these issues with his technical expertise. So, now, once those things line up, now we have a verification process taught by Dr. Martin, that we can slice this and look at it from inside. So now we slice that two phases and we'll match those up and see how they're lining up. Because sometime in stone model there are some discrepancies which we're going to bypass that, but as long as it lines up, so you can see on the right hand screen right there, and we are rotating it, it's just completely lining up. Even though you can see some of the discrepancies there, but it's completely lining up. So that means our timing will be correct and the vertical height of the implant will be exactly what we have in mind.
Pictures are nice, but this 2D cross-section, there's no question about it. And we won't do any of ours in any of my Andover labs without them doing a buccolingual and a mesial-distal 2D cross-section to verify the walls are lined up.
And there we go. Once that was verified, we told software to go ahead and put the implant in place, and the implant was placed digitally at the right place with the right timing. So now we're going to go ahead, bring a tooth in that place. So there's another design. This is a library tooth right there. That we have many different libraries of the teeth in the system. We can match up with that, or we can cut out the tooth from the other side of the arch and place it there, so it will look like exactly the same mouth and same scheme of the bite. So I'm going to go ahead. I'm going to copy from the other side and place it there.
Some of these tools you're seeing Shuaib use now are why labs want to use the 3Shape software over other softwares that are out there. They have basic concepts down, but the power of some of this stuff that 3Shape has developed, nobody's matched.
And especially very critical when you're doing one central and you want to match it exactly with the other side. If you're doing number 8, if you want to match it to number 9, you can just take that number 8 and make the mirror copy of it and place it on the other side. Now you have width, height, and the placement of the tooth perfectly there. Obviously, each tooth you need to customize it, because look at that, it's just because of tissue missing and all that stuff. So obviously we have to broaden up our contact, so we would have that triangle in that area. So but these 2 red spots telling me where my bite is and how much is penetrating in this tooth. So we can reorient that and put it in the right place. All we need to do is just bring it down and fill that space. So right now we are designing a full crown first, and then once this is, when this crown is designed, then we can go ahead and design our custom abutment that would have ideal emergence profile and design for this tooth. Not, you know, as Dr. Martin was explaining, that yes, we can use the stock abutment, but we do not use any stock abutment in our lab anymore, because you cannot have the emergence profile that we're looking for. Now, this particular crown will be a screw retained crown, so we're going to bury our margin a little below the tissue, but still would have ideal emergence profile. Had it been a cement retained crown, then we probably will leave it at the tissue level, especially on the buccal, but on a lingual and mesodistal contact, we'll bring it up above the tissue so you can clean up the cement easily. Now, so this particular type of crown, we call it screw mentable crown, because there is a custom abutment underneath, and you can cement crown and an abutment right in the lab, so you don't have to, you know, cement that crown in the mouth or clean up the cement. But it all depends if your screw channel is on the right place or included. In this case, our screw channel is just coming out on the right, near the incisal edge, but not quite towards the buccal, and we could get away with the screw mentable type crown. So, now this is where our tissue, this black line is our tissue. So you can see that here. I'm gonna probably try to pull a little bit more below the tissue here, so we can hide it and you don't see this zirconia and metal junction. But in this case, we don't have enough running room. I really like my implant right here, so I would have the ideal running room. But in this case, we were very, very tight. our design phase will be done in next few minutes. And after that, we have a model phase, and I don't know if time allows us to show you how to design a model. It's almost,
I don't know if we need to show the model
Okay.
design. They know that we can make that model
Right.
with it being an abutment board. It's fascinating to watch, but I know it's getting late. So let's pause at that point, and
Mhm.
then if some of us.
If anybody
wanna go
has
back to the
questions. So-
scanner, or if someone want to talk to you more about that,
right,
we certainly can.
okay, so we should finish that.
What Schwab's going through right now, that emergence profile, that to me is where it's all at. I need to create a nice natural flow from that crown down into that root, and that emergence profile is that transition into the root. And if I don't have the room and I make that too much like a satellite, it may give me aesthetic look for a while, but it creates food traps. So this is something that there is no right or wrong. It's more important that he interacts with you to make sure we take care of your personal preferences, but that we do everything that we can to create that perfect crown prep with that perfect emergence profile. And that's where I think more and more interaction with TeamViewer now, I can have you on the system live with control, whatever, see, I can snap a screenshot or two and send them to you in a matter of minutes, so that we get more and more interaction. And I think that for me to do that with classic impressions, classic wax-ups, it just wasn't possible. With digital, I love seeing more interaction between the implantologist, the dentist, and the lab, so we get the digital solution that you want.
You said you liked the scanner that's over here, but that needs an STL file to send something to you.
No, this one is a direct link to us because we use the 3-shape system, and this is a 3-shape system also.
Okay.
I don't know if that has a capability to pull out STL.
Yes.
Yes.
Let's just say if you're not sending it to me, and if you have the scanner and the lab you're sending it to, they do not have 3-shape system, then you can actually pull out a STL scan and send it to them so they can incorporate in their CAD system and work with it. But we have a direct link with them, meaning, the scan is gonna come to us through their web portal. So it's gonna show up in our system, and we can just pull it from there and start working, and it's not gonna be STL format, it's a different format that's their own proprietary format.
As much as I love Schwab and as much as I love 3-shape, there is the real world out there. You may have a boutique lab that you want to do business with. As of last year, the Trios now can scan an STL, and you could send that to somebody if they had a Zircon or an Armin Gerbach system that uses ExoCAD and doesn't use 3-shape. You now have the ability to send them that STL file so that they can work with it too.
So while we were talking, I don't know if you have seen it already, that I designed a design feature in it. I put a anti-rotation slot in it, which is our insert direction also. For instance, if this wasn't a screw retain crown, if it had been a cement retain crown, this would help you guide your crown. It would be self-guiding mechanism to the crown. That tapered groove that I created in. So we design in every single custom abutment, we design this guiding groove in every custom abutment. So from there, once our custom abutment is designed, our crown is designed, all we need to do is connect to, fine tune it a little bit, and there we go. We can send our custom abutment to 3i, and we can mill our crown right in the lab and print our model also. So there we go. We brought our crown back. We're going to be connecting to the margin, fine tuning. See that we made this crown a little bit longer, so now we're going to be connecting to the margin. There we go. Connect to the margin. Obviously at that point it's just a rough connection. We're going to go ahead and smooth all those areas, and get a very natural looking crown that is matched to the anatomy of the other side. right
See
here,
those?
margins are a little bit overhang. That's how the zirconia milled, and once we have milled our zirconia crown, we're just gonna go put it right on top of the abutment and smooth it out, so now there is no overhang of the margin. I'm gonna stop my design here, it's pretty much done, and we can have question answers if,
Just one quick thing, where you saw those little red circles for the contacts? The beauty of that is that we can now work mathematically with you. So if you get a couple of them and say, you know what, your contacts were a little tight, Shuaib. He knows that what set those circles, he had set to .05. So he can set it to .04 and ask you how your contacts are. Once we get it to where that contact, you're comfortable with it, 97% of the time, those contacts are gonna come back the way you want them to. Because we've set that mathematically, and 3Shape is very, very consistently accurate with that stuff. So we can get, and that's where we start getting the models. He says, Craig, the last 7 crowns, you know, they're perfect, Shuaib. But why am I even sending you a model? So we do see modelless cases now. We're not gonna see modelless dentistry for a long time, but we do see modelless cases, and more are asking for modelless cases. Does it save money? It might save money. Is it bragging rights? It's kind of bragging rights, but it streamlines everything for all of us, doesn't it? So I don't want anybody to ever think that I think we're ready for modelless dentistry. Because if I want my facial cutbacks, like I showed you before, I have to have a model for him to layer that porcelain on there. If I want to do copings and do a full porcelain, I have to.